Okay, so today we will start with lab, right? So let me explain you the lab topology. Okay, so we have again two leaf pairs, leaf 1A, 1B and 2A, 2B. Okay, and this leaf 1A, 1B has two SVIs, VLAN 110 and 111. And 2A, 2B has different two SVIs, which is 112 and 113. So basically there is no overlapping SVIs, right? It's a pure symmetric IRB where there is no VLANs which SVIs which are overlapping or exist on both or any of this, both of this, right? So host H1 is in VLAN 110, 111, H2, H3 is 113 and 114, right? So this is how it is configured. And yeah, it's a leaf spine. Now for underlay, right? For underlay, we are running OSPF. So basically underlay to learn this loopback addresses, right? To establish EVPN neighborship, correct? We are running OSPF. Also to exchange this VTEP routes, right? VTEP subnet to each other, right? That also is done by OSPF. So basically underlay is OSPF in this scenario we are using, right? Another peering is IBGP peering between leaf 1A, 1B, right? For link redundancy in case, this uplink goes down, still H1 can send traffic via this path, right? So that's so basically underlay is OSPF to advertise all these loopbacks, right? And also VTEP IP addresses. So VTEP to VTEP reachability is also through OSPF. And we also have IBGP between leaf 1A, 1B, MLAC peer. Okay. So that is about underlay. Overlay, that is EVPN neighborship, right? As you know, we can use either IBGP or EBGP, right? We can use any of this. So in this scenario, in previous scenario, we have used EBGP, but in this scenario, we are going to use IBGP, right? So basically what we are going to configure on spines, on both spines, we will configure all these leaf devices as route reflector clients. So spines are route reflector, right? Because it is IBGP, we don't want to create full mesh. So what we are going to do is spine and 1 and 2 are route reflector and all the other leaf pair devices are client, RR client. Okay. So that will be the configuration. Okay. And this is VLAN 110, 111, 112 and 113. Okay. So this is how it is spread across, and virtual MAC is same across. Any question on topology? Anyone has any question? Is it clear?
Yeah.
Okay. Okay, so let me show you the configuration, right? Where is that? Okay, so let's start with OSPF configuration, right? Show run sec OSPF. Okay, so basically this is the OSPF configuration, right? And yeah, we are running OSPF only on the interfaces where we need to run it, right? So basically, yeah, this is the OSPF configuration. And if we check the route, right, show IP route, you can see that all this. So basically the subnets, right? Let me just arrange this. Yeah. So all this subnet, right? 255 and 254. 255 is loopback 0 and loopback 1, right? So we are learning 255 subnets, right? 255.4, 6, right? Through OSPF towards the spine. These are the two next hop for the spine, right? And again 254, right? 254, that is 254.3.3 is this VTEP and 254.5 is another VTEP. So that also we are learning through OSPF, right? So basically all the routes, loopbacks, right? We are learning through OSPF, and this was the OSPF configuration. Okay. Now let's check the BGP configuration. So BGP, we have EVPN neighborship, right? That is,
Vishal, sorry. Can you
yeah,
scroll up? I just want to check the spine. Okay. Dot 4 is reachable by Ethernet 1 and VLAN 4093.
yes.
Okay.
Oh,
Okay.
okay. So I actually, in this case, between leaf 1A, 1B also, we are running
Oh,
OSPF.
space.
Okay. It's not
Okay.
IBGP. So I mentioned that,
Yeah.
between these two, we are running IBGP, but that's not the case here. We are running for all underlay, right? Everything in
Hmm.
underlay, we are running OSPF, right? Okay.
Okay.
Yeah. And that's why I also got surprised when I saw there is only EVPN neighborship, right? So yeah,
Hmm.
in this case, we have OSPF underlay. And as you can see, and you pointed out, right?
Hmm.
For this subnet 25.4. No, this one, right?
This one.
255.6. So where is 255.6? Yeah, this leaf 2B to reach on leaf 1A to reach leaf 2B loopback 0 IP address. We have what two route. One is 255.2. 255.2
Ethernet
means spine 2.
spine
And
2.
we are also learning through 4093, right? That is the
Hmm.
neighbor. Leaf 1B.
1B. Okay.
Leaf 1B.
Hmm.
Yes. Okay.
Good.
So yeah, that's how 254.5. These are two spines, right? 255.4 also is, yeah, Ethernet 1 and 24093, correct? So it is through spine 1 and the neighbor. Okay. So that's how we are learning the basically the reachability is, right? You might can check if you want, or look into that, what is the reason we are learning from this also, right? And why there is no, we are not there is the third path also, spine 2, right? For one route, this that is not there. So maybe you can check later, if you want to explore more on OSPF side. Okay. And yeah, otherwise it is from spine only. Okay. So any other question? Okay. Okay, so now let's discuss EVPN, right? So yeah, we have EVPN neighborship, right? Only BGP neighborship is EVPN. Okay. And as you can see here, it is remote AS, update, loop back, send community, maximum route. And these are the EVPN neighborship with the spine devices, right? 255.1 and 255.2 is your spine devices, correct? So you have this EVPN neighborship active, right? You also have put route map to make sure or control the route, right? Well, which you want to advertise and which we want to receive. Okay. And then this WRF configuration. So this is new compared to asymmetric IRB, right? In asymmetric, we have only MAC WRF configuration. And what we use is VLAN base, where for both the VLANs, VLAN 110 and 111, we have separate RD and RT, right? But right now in this scenario, we are using VLAN aware bundle, right? Where we have VLAN 110 and 111 are bundled into one MAC WRF, and both has same RD and RT value. And we also has redistribute learn. So as soon as we learn the MAC address, we will advertise that. Okay. And then we have also have to configure WRF, IP WRF, right? Because there is no SVI which are common, and we need to basically traverse the basically forward the traffic using IP WRF, common IP WRF. So we have common IP WRF, right? This is the route distinguisher, and these are the route targets. And we also have redistribute connected. What does that mean is whatever route, right, into this WRF, connected routes into this WRF, that will be advertised into EVPN. Okay. Is it clear? Any question? Any question on this part, BGP configuration?
Vishal, just one note. Uh, so here we have in the WRF IPv4 config, we have route target import EVPN, route target export EVPN, right?
Right.
So uh, in
Okay.
the
Yeah. This one.
yeah.
Yeah.
What if we don't give a EVPN? If we don't add EVPN here, will the VPN like type routes not be imported?
Okay. So basically why we need to configure this is right because we need to advertise this routes, right? So basically why we need to configure IPv4, right? Because this VLANs, right? VLAN 110 and 111 in symmetric IRB, it's only on this devices, right? Here it is not there. So let's say you want to communicate between 110 to 112, right? H1 to H3. What you have to do is you send the packet to the gateway, right? Now you need something common on both of these through which you can route the packet, right?
Yeah.
So that's where you need to assign one particular, in our case, we assign WRF A, right? WRF A. And we also assign VNI mapping for WRF A.
Yeah.
So through this VNI, so when this packet data traffic you send, right, H1 to H3 ICMP traffic you send, this will have VNI of this, whatever we have configured for WRF A. So when this lands here, it understands that, hey, this traffic I have to put in this particular WRF, right? And from that WRF, it will check the destination IP, which is nothing but directly connected subnet 112. And then it will, based on ARP, it will forward the packet, right? So basically we need one common WRF, and that's the reason now you want to advertise this. So basically now let's say you have to send this packet to 10.1.12.103, right? From
Yeah.
here. Now this SVI 112 is not present here, right? So obviously you will not learn ARP for this guy, right? H3, because that is not present. SVI is not present.
Yeah.
So ARP is out of question. So what you have to do, you need to learn the route for this guy, right? So what is the route? 10.1.12.103, right? Slash 32. Correct.
Yeah.
Now, so basically you have to advertise this route from here, right? Now you have to add route distinguisher so that even though it is possible that below there is one another in another WRF, right? This is say WRF A, there is another WRF B where same IP address also exists, say another customer. So that's why you need to add RD and RT, route distinguisher and route target, right? To basically make sure that you receive this route into this WRF routing table, right? So right now in this case, we are just discussing about one WRF, WRF A, okay, A. But what if there is another WRF B as well, right? WRF B as well, which also has similar subnet. So that's why, right, we need to assign RD and RT so that you send that packet and receive that packet into this WRF. And all these SVIs, right, are part of this WRF, WRF A. Okay. Is it clear or should I explain again?
Yeah, this is clear. So my question is like in the route target configuration, right? We have
Mm-hmm.
the import EVPN, like import EVPN. We have the string, right? So
Mm-hmm.
is there any significance? So in because in the rest of the config we don't have this EVPN keyword. So here we are adding.
Oh, EVPN keyword you are. Oh, okay, okay. Yeah. Basically, this keyword is just to mention that this route target is applicable as a EVPN. So let me go to, what was that? Yeah. WRF 10 and A, right? Route target import. So if you see here, right, see, it's not only EVPN through which basically protocol through which we can advertise this type 5 routes. Okay. We can also advertise same route for VPN v4 using VPN v4, and we also support that. Right. So let's say you want to configure address family instead of EVPN, same functionality, but you want to use address family VPN v4, right? IP VPN v4. So what you have to do is basically the config chain will be in address family, right? You have to type VPN v4. Basically, yeah, IPv4. Okay, and there was VPN IPv4. Yes. See, so basically you can, so here in address family, you can type VPN v4, right? And then this neighbor. And after that in route target also, instead of EVPN, because now you are using VPN v4, right? As an exchange type 5 mechanism, you have to use here also VPN v4 route target. That's it. Okay. So basically it's a different ways we can configure this. Okay. And that's how we have to use this. So if instead of EVPN, you want to use VPN v4, you have to configure VPN v4 and activate this EVPN, basically neighborship. And here also you need to mention VPN v4.
Okay, understood. Yeah.
Okay. But otherwise it's same, means either EVPN or VPN v4 as far as means mostly concepts are almost same, right? It uses RDRT, and in fact before EVPN in MPLS, VPN v4 is what use maximum for L3 VPN. That is also called L3 VPN or VPN v4. So that what basically in service provider, that is what they used instead of EVPN. VPN v4 is what they use more. Okay.
Yeah.
Okay. Any other question? But yeah, that was good. Good one. Any other question? Okay. So let me show you. So yeah, the other config is interface VLAN 110 and 111. As I told you, right, it is in WRF tenant A, right? So all the VLANs are under WRF. Okay. 4093 and 94 are for, MLAC peering and basically MLAC peer and then underlay routing, right? And let's check show run interface VXLAN 1, right? So this is the VXLAN configuration, source interface loopback 1, right? I'll explain this maybe in next one. And then UDP port 4789, VLAN to VNI mapping for both the VLANs, VLAN 110 and 111. And as we discussed, we also have to configure WRF, right? Tenant A. So basically this WRF with VNI. So if you check here through interface VXLAN 1, right? So it is source interface is loopback 1. It is EVPN, the application mode is EVPN, right? We are learning through EVPN. Remote MAC learning is also through EVPN, right? And this is VLAN to VNI mapping. And as we can see here, we have configured dynamic VLAN, right? So as soon as we configured this WRF tenant A and VNI 10, which is nothing but VLAN to VNI mapping, WRF to VNI mapping, we also configured dynamic VLAN, right? 1197, and this VNI is mapped to it, right? So basically we have created dynamic VLAN for this VNI. So these are all mapped in one, right? WRF to VNI and also dynamic VLAN. Okay. So yeah, this is the configuration of leaf. And if I have to show you spine config, right? So this is the spine configuration as discussed, right? It will configure route reflector client. So all these leaves, right? 4 leaf pair, 3, 4, 5, 6, they are route reflector client for this spine device. So you don't have to do, you just have to configure route reflector client, and that way this will become route reflector. Okay. And if you also need to configure cluster ID, right? So this is how you can configure on spine route reflector configuration, all the 4 leaf devices. Okay. And address family, you have to activate it. Okay. Any question for as far as configuration is concerned? Okay. So in that case, I hope lab topology is clear. Let's quickly go through the configuration part. Yep. So it's VLAN 110.111. You also have to create WAF, right? And also enable the IP routing for that WAF, right? So these are the common config with symmetric IRB, right? And then both of your VLANs should be in WRF A, right? So here 110.111 and the other side leaf 2A 2B 112.113 also part of WRF A. So basically all the communication is in same WRF. Okay, WRF A. Next is VXLAN configuration, source interface loopback 1, right? And VLAN to VNI mapping for both the VLANs, and then WRF to VNI mapping. Okay, so which is same on both sides. And next is BGP config. So an OSPF, right? So yeah, we have OSPF configured for underlay, right? Underlay. And for overlay, we have EVPN neighborship. So there is nothing as far as route reflector on leaf devices, right? There it's nothing. It's a normal EVPN BGP configuration. Just on spine, you have to mention that this neighborship, right? All spine leaf neighborship is RR client, route reflector client. Okay. But otherwise here it's normal configuration, address family EVPN activate, and then you also have to activate, deactivate, basically not activate the IPv4 neighborship, right? Because we have already underlay OSPF. We don't need this on this loopbacks BGP. And then again, the configuration related to BGP VLAN MacWAF config, right? So here VLAN aware bundle tenant for this is the MacWAF, and we have same RDRT value for both the VLANs 110.111. Opposite side also it's same. So it's for 112 and 113. You have similar RD and RT values. Okay. For VLAN aware bundle. And this is WRF tenant IP WRF configuration, which is nothing but import and export route target and redistribute connected. And here it's redistribute learn. So as soon as you learn the MAC address or ARP, you will advertise that as type 2 route. And here, as soon as there is a connected interface subnet, right? In this WRF, you will advertise that route as a type 5 route. Any question? If any part is not clear in this. Okay, so yeah, let's check the config basically commands, right? Different commands. So show interface VXLAN1, we already discussed, right? Another is show EVPN, show BGP EVPN instance, right? So basically VLAN aware bundle, right? For tenant A in EVPN instance is, and you can also see here that VLAN aware bundle, right? It's a VLAN aware bundle and route target 1010 and RD, encapsulation type VXLAN. So this is one. We can also check that EVPN neighborship is up or not, right? EVPN summary. So yeah, both EVPN neighborship with spine is up, right? And we are receiving the prefixes, around 15 prefixes as received. Show BGP, VXLAN, show V flood VTAP, right? Flood list, show VXLAN VTAP. Yeah. So we have this, flood list populated for unicast. But if you remember, right, we did not, we do see here VLANs, right? So this VLAN, so this VTAP IP is for which VLANs, right? And also, if you remember, show VXLAN flood VTAP, we see here VLAN 111.110 and VTAP IP address, right? In this command. If you remember here, there is no mapping, right? VLAN to VTAP. Basically, flood list is not populated. My point is that, right? For VLANs. Can you tell me why flood list is not populated here? Or my question is first of all clear?
Yeah, those VLANs are not common among the leaves, right?
Okay. So, but
So
if we check here, right, type IMAT detail, right? So we are receiving IMAT route, right? Type 3 routes for other VTAPs. So this is local, right? These are local. So that is fine.
but we won't have that route target for that particular VLAN defined, right?
Okay.
On that,
So
so we
yeah.
won't install it.
Okay. So this is the type 3 route, right? 254.5 for this VLAN 112 we are receiving, correct?
Yeah.
And then what 254.5 route target is 1010, right?
Yeah.
So that is that we have, right? Show run sec BGP. This is same route target, correct? So basically point is, see, let's consider this, right? 10113. So we are receiving this VNI, right? IMET route for from 254.5, right?
But
And
this route target is for the macro.
yeah, MacWof. So
Yeah.
type 3 is for MacWof, right?
Yeah.
Type 3 is MacWof, correct? So
Uh-huh.
if you see here, we have this same route target, right? 1010.
Okay. But okay, the VNI, like, can you do show interface? Show run interface VXLAN? Yeah, but we don't have that VLAN to VNI mapping, right?
Yes. So that's right. So yeah, so route target is same, but because this VLAN does not exist here, right? We don't need to flood VTAP of that, right? That VLAN, correct? Because what is flood? Why we need flood list? So if we have any bump traffic for that particular VLAN 113 here, then only we need that flood list. But because this VLAN does not itself exist here, we don't need flood list for that, right? So that's the reason, even though we are receiving type basically type 3 IMET route for VLAN 113 and also VLAN 112, we are not basically updating or seeing flood list into VXLAN table, right? Is this clear? Any question on this? Okay. Yeah. So basically, this is how we will learn the basically receive type 3 update message, right? IMET route. If there is a common VLAN available, then we will update it, right? And it has all this information. Okay. So yeah, that is all about, type 3 route. Oh, sure. Yes, this is, yeah.
Can
Any
you go
question
back, Vishal? Can you just go back
on this one?
on the slide?
Okay, yeah, yeah.
One more.
Okay.
Uh, well, I think over here the friend list is popular.
Yeah, and this maybe, we have, I have might have copy pasted from that,
Yeah.
symmetric one. But yeah, good observation. Let me remove this.
Yeah.
Otherwise, people might get confused. So yeah,
Yes.
okay. So anything? Yeah. So this is how what we received IMET route, and as we discussed, right? This is only shows as unicast, but there is no VLANs, right, associated with that. And this is VLAN to dynamic VLAN to VNI mapping, and also tenant to mapping. Now next is show dynamic VLAN. Show VLAN dynamic. Yeah. So as soon we configure this, right? Sorry, show run interface VXLAN 1. As soon as we configure this VXLAN WRF tenant A, WRF to VNI mapping, right? We basically create this dynamic VLAN for EVPN, which is 1197 in this case, but it can be any. So if you remove this config and configure it again or reboot the device, you might see that this is changed, right? So it is dynamically created for EVPN. Similarly, there are other dynamic VLAN may be configured, right, as and when required. But we can see that we have created EVPN for EVPN dynamic VLAN, right? 1197. And same is also we can check, right, into show VXLAN EVPN table. Show interface VXLAN 1. Okay. Another is show MAC address table. Show VXLAN. Yeah, VXLAN address table. Okay. So if you see here under VLAN 1197, which is dynamic VLAN, we have learned this one MAC, right? This MAC address over VX1, and through which VTAP? VTAP 254.5. So if you remember, that VTAP is the other side VTAP, this VTAP 254.5, right? So basically over dynamic VLAN, right? We are learning this MAC address through this VTAP IP. So basically, if you remember, because we don't have overlapping VLANs, right, or SVI, we create WRF, right, IP WRF, right, so that we can transit the traffic through this WRF. And as soon as we create the WRF, we create dynamic VLAN, in this case 1097, right? So basically, now this VLAN 104097, right, it is, what was that, 1197. Okay, 1197. Okay, so 1197. So now, because when you have to forward this traffic, right, to this H3, you have to put source MAC as this MAC, right, this MLAC system ID MAC, and destination MAC as of this VTAP, right? That is what we have to, that will be the destination MAC. So in that case, you are learning, basically you need to know how to read this destination MAC, right? That VTF, and that MAC is nothing but system MAC, but it is because of MLAC, it will be system ID, MLAC system ID, right? So this MAC you are learning over VXLAN, right? And basically, you know that for this VLAN 1197, right? I have to send this packet, this for this MAC, right? 2A, let's say MAC 2, right? I have to send that packet to this VTAP, right? So that's what we are learning here, right? Say 1197, this particular MAC of the other side, right? We are learning on VLAN 1197 through VXLAN, and this is the VTAP IP address. Okay, is it clear? Any question? Because if you remember, show IP route WAF all, right? So if you have to send packet to the other side, right? 10, 11. So basically here we should have also learned /32 route for that subnet, right? And you need to send that packet to this MAC, right? The other side MAC. But you need to know how to send this packet, right? This packet. And that's how you will basically you will learn that MAC over VXLAN address table, right? So yeah, this is how it will basically Basically you will learn the MAC over dynamic VLAN. Okay, any question, or is it's not clear? Yeah.
Vishal, so that dynamic VLAN, is that picked from a specific range, or
Uh, uh, so they internally they have assigned one range, but if you there is a command through which you can configure or decide range, right? You can also
okay,
give one range by command so that you can say that, hey, use only from this range. So that is also possible.
okay, so we should not use VLANs, normal VLANs from that
Yes,
range.
overlapping. Correct, correct.
Yeah.
So
Okay.
basically, by default, it uses from later part of this, like 1197, 1198 only,
Mm-hmm.
right? But yeah, if you want to, let's say you are using in your case also this VLAN, right? Then better to configure range and avoid this particular VLAN, right? If because this is VLAN is for your data traffic you are using.
Sure. Okay.
Okay. I'm not sure internally they check that, hey, this VLAN exists and I don't assign dynamic VLAN for that. Possibly that check should be there, but yeah, you have that command to assign range to use. Okay.
Okay. Cool.
Okay. Any other question? Okay. So now next is type 2 routes, right? Okay. So yeah. So okay, let me show you this one, right? So MAC. So basically this one was the MAC, right? So VXLAN address table 552A, right? 552A. So where is that MAC? Show version. So this is not the one. Show version 552A, right? So if you check show AMLAC, this is the system ID between these two AMLAC pair, right? So that's why we are using this 552A, and that is learn over VXLAN. Okay. And if you check this show interface VLAN 1197 on this, right, both devices, that also will yeah. So basically this is what the MAC, but in this case, again, it will use this MAC, right? 9273. Yeah, this MAC. Okay, this leaf 1A MAC, not the 1B MAC, to advertise type 2 routes and also VXLAN address table. Now let's check the type 2 route, right? Show BGP EVPN route type MAC IP. There is no type 2 route, right? Do you see any type 2 route?
Shouldn't it be in BRF?
No. Okay. So
Oh,
see,
sorry.
EVPN table is common, right, for
Yeah,
all
yeah.
the WAF, right? Based on RD and RT, you will differentiate that, hey, I have to pull this into this route, which routing table, WAF routing table, right? So EVPN table is common table where you have all the WAF, basically all the routes, right?
Yeah.
With
Yeah.
RT and RD, right? So now if you see here, right, we don't have, basically we have not learned the, so one interesting thing I want to show you is, see, if you see here, right, I am pinging this guy. So basically I am pinging H1 to H3, right? H1 to H3, correct? I'm pinging 12.103 from H1. This is H1, okay? And it is successful. It's working fine, right? But when I check the route for that, obviously R will not be there for that subnet, right? 10.1.12.103. 10.1.12.103, there is no ARP, obviously, because this VLAN does not exist, SVI. But we don't have route also, right? Specific /32 route. So basically, what should we have, right? As soon as this guy learns the ARP, right, it should have advertised this, right? Type 2 route /32 route. So /32 route for 1.12.103/32 should be installed in this WRF routing table, but it's not there. And still ping is working, right? Can you tell me why, and why route is not installed?
Can you check the route map?
I think because there is no SVI for VLAN 103 on
Correct.
level
So
1A.
yeah, so there is no SVI 113, right? And that's why we are not learning in ARP, correct? So basically, when when this guy advertises this type 2 update for MAC IP ARP, right? If you have SVI 113 present here, 113 present here, you will update the ARP table, right? Based on type 2 information. But if this SVI is not present, what you will do is, instead of ARP table, you will update the route table under that WAF, right? So basically you will update that 10.1.12.103/32, correct? And then next hop should be this VTAP IP address, this virtual MAC, basically this MAC, right? So that is the all information we will have, right? Is it clear?
But there were no type 2 routes also over there, right?
Yes, so that's the point, that why there is no type 2 routes, right? How we will basically troubleshoot. And another question is then how it's working, right? This ping is working, correct? But if you see here, there are only type 3 routes, IMET routes, and type 5 routes, IP prefix route. There is no type 2 route. And ping is working, by the way. So any idea?
But it would not need type 2 route, right?
Why?
Uh, it should forwarded by. Can you do show IP route?
Yes.
It should still forward by this 10.1.12.0/24.
Yes. So you have learned this route through which type 1, 2, 3, 4, 5, what?
This was type 5, right?
Type 5 route, right?
Yeah.
So basically what happened is, because of this config, right? Show run sec BGP, redistribute connected, right? Basically this guy leave 2A, show IP route WAF route of all, right? So this 10.1.12.0 subnet, right? Which is nothing but this subnet is directly connected. And because we have configured show run sec BGP redistribute connected for this WARF IP WAF, this directly connected route will be advertised as a type 5 route, right? So show BGP EVPN route type MAC IP prefix IPv4 detail, right? So basically we are advertising this route 10.1.10.0. What was that?
112.
What is our subnet? 10.1.12.0, right?
12. Yeah.
12.0. Yes, this one. So basically we are 12.0. So we are basically it is because of connected route, it will advertise this route type 5 route, right? With what are the information, that route target is 11.11, right? That route target is this. I have changed this 11.11 because this was confusing, right? Both were same. So for MacWAF, I am using route target 10.10, and for IPWAF, I am using 11.11. Okay. So we are advertising that route 12.0. Where is 12.0? 1 minute. Let's 10.1.12.0/24. Fix 10.1.12.0/24 detail. Yes. Yeah. So basically we are advertising with route target AS 1111, encapsulation VXLAN, router MAC this, and VNI is 10, right? So basically, yeah, we are advertising this route as a type 5 route, and same route we will receive here, right? So EVPN route type IP prefix 10.1.12.0/24 detail. So basically we are receiving this route 12.0/24, correct? Next stop was to basically from that VTAP, and this is the originator and route target 1111, right? And VNI 10 because IP worth VNI is 10. Show run interface VXLAN 1. This is the VNI, right, for IP WAF. So based on this, we will update our routing table, right? Show IP route WAF all. That 10.1.12.0/24, the subnet we have received. So basically, yeah, we have received this subnet prefix through VTAP 254.5, 254.5, right? Next up. And VNI 10 through on VNI 10, router MAC is 552A, right? 552A and VXLAN 1, right? Over VXLAN 1 interface. So this is the route we installed. And because obviously we have not learned the most specific route /32 through type 2, but because this is already available, /24 route is already there, we will forward this packet. So basically this guy will send the packet to the gateway. Now it will check into WRF A, right? Into WRF A. This packet lands into WRF A because this SVI is in WRF. So it lands into WRF A, it checks the destination, it checks first the route, right? And for this subnet, the subnet /24 route is available, and which is saying that, hey, to send this packet, any packet of this subnet destined to send to this VTAP, right? So we will encapsulate the packet, right? And send it to this VTAP. Source MAC will be this MAC, so system MAC, destination MAC is this MAC, and that MAC is already we have learned here, right? So basically this is my destination MAC. We will check, hey, how to read this destination MAC, right? VXLAN address table, and I also know that this is behind this VTAP, right? So basically we will send that packet to this guy. This will land based on VNI 10. It will land into this WRF A, right? Then it checks the destination IP. It is directly connected SVI. So it checks the R for this guy and send the packet out, right? So even though /32 route is not advertised or learned here, we still have ping working, right? End to end. Is it clear? Any question? Is it clear? Or do you want me to explain again?
I'm okay.
Okay. So now the question is why, this route is not advertised, right? How can we, why we are not receiving basically type show BGP VPN route type MAC IP, right? Why we are not receiving?
Can we check the other leaf if the locally we are to select?
Okay, show R of all, right? Okay, so this is the entry 12103.
It's not learned. I think once we ping it,
Okay, so from where to where you want me to ping?
we can ping from leaf to where to post directly.
Okay, ping.
12.103.
We have to ping in WAF, right?
Yes, yeah.
So many times we miss this, right?
I was like, IP is correct.
Okay, so yeah,
Hmm.
ping is not successful. So let's check ARP. Yeah.
It's not learned. Can you check the MAC?
Show MAC address table.
What VLAN was this?
VLAN 112, right?
Eh, yes.
VLAN 112. 12.103.
This is no, this is not
Wi-Fi 2A,
MAC.
right? Let me check
Yeah,
the MAC.
MAC
MAC
is not
is
there.
AF4D4. Yeah, so basically we have not learned this MAC, right?
Yeah.
Why?
Can you start the traffic from host? That's why it's not learned the MAC.
From where? Here?
Yeah, the host. Yeah. Then ping the gateway of
10, 1, 12. What was the gateway? 12.1, right?
yeah. It should
Okay.
have it now.
Show up of all.
Yeah, port channel.
Yes. But the point is, right? When you ping from here, right?
Mm-hmm.
Why you did not? You should have learned the ARP, no? When you
Yes.
ping from C1 leaf to A, correct?
Mm-hmm. The broadcast should still go and it should still reply and the MAC should be learned.
It is possible that you send this packet app request from here and it reply might landed on leaf 2B, right?
Hmm.
But still because it's IP address virtual,
It should sync.
it should have synced, right? Maybe, but now, yeah, now it's learned. What else? What do you want me to check now?
Now it's working. Let's clear the ARP.
Yeah, but now
And
there's still the problem of type 2 route, right? Not advertise or that.
should be there now, type 2 route, right?
Okay, let's check that. Yes, it's there, right? So basically so this is how you can basically troubleshoot, right? That why type 2 is not learned. So you check first, whether the other side ARP is learned or not. And if ARP is not learned, right, MAC is not learned, then you can basically check why MAC is not learned. And then basically you can follow the steps, right? And one more good thing is, even though type 2 route is not learned /32, you still able to your traffic will still pass because of type 5 route, right? But one problem here is with this, right, where /32 route is not learned, right? What might happen is let's say there are another VTAP, right? Let's say your topology is combination of symmetric and asymmetric, right? Symmetric and asymmetric. So you might have this VLAN 112 here, right? So in that case, your traffic and host is this, right? You want to send traffic to this. Now this traffic might go here because this guy is also advertising type 5 route for this subnet. And then from here, it will land into WAF route to 112, and then it will, based on ARP, it will forward again. So there is possibility of traffic don't go directly, right, to this VTAP, but still it should work. Obviously, if ARP is not learned, then it will not work here, right? ARP is not updated. It will send ARP request, reply should receive here. Okay. Basically, reply will not receive, but as soon as this guy learns the ARP, it will send type 2 route, right? And that way this should basically forward the traffic. Okay. Okay, yeah. So do you want me to clear, right? clear ARP of yeah, it's clear now.
Okay. Mac is also clear. Let's check Mac as well.
Yeah, I think should
No, it's still
be,
there.
yeah.
Let's clear
Mac.
that as
This one, right?
yeah.
Okay. What happened? Clear MAC address
Address
dynamic.
dynamic.
Okay. Oh, yeah, gone.
Oops.
So
Now the type 2 route should also be gone. Let's try and ping to and from host basically.
ping, right?
Yeah.
Ping of tenant take what was that? 10.1.12.103. Show up of all, right? Not
And art is learned
oh,
now.
this time it has learned.
No.
Okay.
So the ICMP reply could be hashed to the other.
Oh yeah, that is possible. And ARP sync has happened, right? This time.
Yeah. This time art sync happens.
Yeah, TCP dump interface. What was that? VLAN 112, right?
Hmm.
Ping. No. TCP dump -I VLAN. What was that? Team 0112. Okay. Permission. Okay. Sudo. Okay. Echo request is received here, right? Why it's
Right.
not working? Can you tell me?
Can you see which MAC address it is sending? Is the ARC there for on the host for the gateway?
ARP, right? Sudo ARP. Yeah. Okay, let me, yes, this is the host. So if you see here, we received ICMP request, right?
It's not replying.
Yeah, it's not replying. Why? Yeah, this one
Can
is good,
this
interesting.
can you send what MAC address did it use? Source MAC address?
Yeah, we can. NEVI, right? NEVVI. Yeah. Yes, this is the MAC.
Okay, so it is using physical MAC.
Yes. Then in that
But
case,
it's
there
just
is no issue also, right? It will learn
yeah,
to this guy only. But the problem is this guy is not replying back. Why?
replying. Because in the ARP, the destination MAC would be the MAC. Yeah.
Oh, ARP is
Just
learned, right?
yeah.
Anyone else? Any idea?
What's the routing on the host?
Okay, IP we check. Oh wow, IP route. Yeah, this is the route.
So we don't know.
Oh
There's
no,
a
this
different
one,
route.
right? 10.1 default is this, yeah.
No, but there
This
is 24/24.
10.1.0.0, yeah. 10.1.0.0 is here.
No, that there's 10.1.12.0/24 as well underneath that.
Okay, yeah, that is
Load.
basically
What is Scope
Yeah,
link,
but
local.
Basically, this is what it will take, right? This is the gateway, correct? And so
Yeah.
basically for all the subnets, it will send out this guy, correct? To the gateway.
Yeah.
You're all the
yeah,
subnets.
yeah, but is there the ICMP seems to be was 255.
Yes, right. Why this ICMP is 255, 10.255.1.5? Why? Why
Which IP
basically
was
leave
that?
2A, send this packet with this IP address, right? 255, whatever it was. 10.1, what was that? 10.255.15. 10.255.15.
What is this?
10.255.15. Loop back
Loop back.
100. Why it has sent with this IP?
Hmm. Can you show the configuration of this loop back 100?
Show run interface loop back 100. It's in this
Uh,
WAF.
Okay. If we source the ping from the gateway, does it respond? It should respond. But why is it sourcing from
No,
one dot
why sourcing from which gateway?
from VLAN 112 basically?
Okay, we can try ping WAF, right? Source.
Yeah.
VLAN 112. Still it's not working. Let's check
Do the same
TCP
thing
dump.
and do the TCP dump. Yeah.
Yeah.
Okay, gate sourcing from your gate VLAN, right?
Yeah.
Yeah, it's always
Still it's
using.
sending same 25515
Yeah.
source. Why?
Was this the NAT thing?
Sorry?
I don't know. Was this the NAT where it's saying it's using some highest loopback? I don't know. There's something we talk about in VXLAN when you're pinging from
Yes,
the
we have
interface.
spoken about this in VXLAN. So point is because see, okay. So show run interface VLAN 112, right? We have virtual IP address, correct?
Yeah.
So basically, if you remember in VXLAN, we discussed when this VTAP send out ICMP request, right? In IP address virtual, right? IP address virtual, it does natting because it does not have physical IP address. So basically, data traffic, right, or ICMP or any traffic, when you ping from here, it always uses system MAC. It never uses the virtual MAC, right? For that. So that's why you have seen here that it uses the physical MAC, right? It always uses physical MAC. It never uses the virtual MAC for data traffic. If you remember the different rules we have discussed in VXLAN, right? So basically what you have to do, basically you are using physical MAC. Now when your MAC is physical, when you send out ICMP request, right? Your MAC is physical, your IP also should be physical IP, right? You can't use virtual IP. But if you see the configuration, you have only virtual IP for this VLAN 112, right? Because you have configured IP address virtual. So there is no physical IP. So what we do natting, right? So we do natting with the IP address, which is highest in this particular IP WAF, right? So as per that, loopback 100 is the highest IP address in this particular WAF. So that's why this guy is sourcing this ICMP request with this IP address because of natting, right? And then what happen, what basically in that case, what obviously can happen and at customer end also, because this is a random subnet, right? Source IP, this guy might not have reverse route for this, and your ICMP will not work, right? That's the reason we should not try pinging from VTAP to the host whenever we are troubleshooting that H1 to H3 is not working, right? Means we can try, but obviously we should know that why it's not working, right? And that is genuine reason we should not continue troubleshooting this part, right? And unnecessary we waste our time basically, because of this reason natting, it might not work, right? So that is not good idea. If ping from this guy to this, or basically VTAP to host ping might not work because of this natting. and that's what we can explain it to the customer. Okay, is it clear?
Yeah, only in case of IP address virtual, right?
Yes. In case of IP virtual router address, it will has its own physical IP of that VLAN, so it will use that. But in most of the cases, what you see is IP address virtual, right? So basically, just keep in mind, if customer says that, hey, this VTAP2 host is not working, don't troubleshoot that. You can explain him that this can be the reason. Okay, or basically you can just check or explain him by using this TCP dump what we did, right? To show him that, hey, it is using this IP, which is where you might not have route for that, right? So that is fine. That's not the problem, basically.
On the switch, can we check by the command what IP would be using?
Yeah, so there is no command, right? It will show that which IP it's going to use, but we basically have to check TCP dump to see which IP it has used.
Okay.
But yeah, basically what you can do is you can get an idea by checking that this
Highest.
in IP VRF, yeah, what is the highest IP, right?
Okay.
Or you can have 2 sessions and run TCP dump at the other side, right?
If I run a TCP dump on the leaf itself, it should still though show me what IP will it show me?
Yeah, it will show. You can run leaf to a TCP dump.
Okay.
Yeah.
So it originates the packet initially with the NAT. Okay.
Yeah. So let's TCP dump interface VLAN 112, right? Ping. Yeah, you can see that, right?
10255, yeah.
10.255.15. Yeah, so this way you can basically say customer that, hey, this is why it is not working, but this is not the problem. But yeah, absolutely you should check ARP and that all is learned or not, right? ARP, MAC and that. But again, when you ping from here, right, you might not update your ARP, which we saw, right? Because the reply will not come back, right? So basically you have to ping from here to if you want to update the ARP, right? You got the point?
Yeah.
Right? Because when you ping from here, a VTAP, reply will not come back. Right? Oh no, ARP request reply should come back. Yeah, sorry. Again, because it will be virtual everything. So that will come back. Okay.
Hey, Vishal, if you do show IP, is it how do we see the IP route, or how did you verify that's the highest loopback in that interface, in that VRF?
Sorry, come back.
How do we verify that that's the highest loopback in that VRF?
No, it's we have to check all the whatever. So I know this IP. That's why. Yeah.
Oh wait, but which IP is higher, or how do we?
So okay, so this is how we can do. See, so we know that our VLAN 112 is in IP VRF, right? So we can check, hey, what are the other, SVIs and compare that, hey, loopback 100 is this IP and 112, 113 is this IP, right? So, and what 1197, nothing. So out of 4, this is the topmost. But again, in customer case, there may be a lot of, right? So best is to take capture, ping from here and take capture here, right? Be 2 session, TCP dump.
Yeah.
You can also maybe run show IP brief only for that VRF.
Oh yeah, let me check. Is it there?
Yeah, it should be there.
No, it's not there. Not there.
Show IP. Oh, that's strange.
Okay. So any other question?
Yeah, and I don't know, I think we may have discussed this. I forgot the reason again. because the ping was working without the /32 route because you have the /24 route, right?
Yes, yes.
Why again did we need that /32 if we still can get communication?
Yeah.
end to
So
end?
basically, yeah, we don't need /32 route, right? We don't need
Yeah.
/32 route. So basically, this route /32 route, we don't need to learn, right?
Yeah.
As far as /24 route for that subnet is present here. Okay. Okay. But let's say it's a combination of symmetric and asymmetric IRB, right? And you
Yeah.
also have the same subnet here, this VLAN 12 here, right? VLAN 12 here, 112 here, right? So this guy also will advertise /24 route, right? So basically now, even though you have to send packet to this guy, you might send packet, you have two VTAPs, which has this full subnet. So you might send it here or here, right? And if you send it here, then again, it will, based on type 2 route, it will forward here, but obviously it will be not uh, 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 proper, right? It will be not, basically your traffic will unnecessarily tumble, go to other VTAP and come back. So that's why it's better to have /32 as well, right? But not necessary.
Okay. Yeah.
Because
Got it.
yeah, because anyway this guy will learn type 30 ARP, right? Type 2 route using, because when it has to send that packet out. So anyway you are going to advertise type 2 route, right? So better it to install to unnecessary avoid this traffic tumbling. Okay. Any other question? Okay, then in that